Welcome back. Let's look at doing another Monte Carlo analysis using the risk solver platform. In this example, we'll emphasize the use of the SciSim parameter function and also how to create an output table that will allow us to look at the results for a different set of input values. So here's a model that I'm evaluating. Assume that I have to make reservations for a conference, and for the number of rooms I reserve in advance, it costs $100. If I don't reserve a room in advance and then more show up than I had planned that would show up, I have to pay $160 a room. Assume that I expect on average 5,000 people attend this particular conference, and there's a distribution of that with a mean and a standard deviation. We'll come back to that in a minute. Then I have my decision to make, how many to reserve, and so I'm showing 4,000. The logic then for how to compute the cost is here. If I've reserved more than actually attend, then whatever I paid up front to reserve those rooms in advance is my cost. If I have more attending than I had reserved rooms, then I not only pay for the rooms I'd reserved in advance, but for the excess rooms that I need, I pay this late cost. Now in this case, I've put in 5,000 for an attendance and 4,000 for number reserved as a starting point. It's important in developing a simulation model that you first develop the deterministic model and make sure that the logic is correct. Satisfied with this logic, then I would need to enter the risk solver platform distribution. And so I'm going to enter it here for the attendance. The function for that, if it's a normal distribution, is equal to psi, psi normal. And then the parameters are the mean and the standard deviation. And I'll just make cell references for those. So I'll select this cell for the mean, comma, this for the standard deviation, and then use that as my distribution. Now, we usually don't have a fractional number attend a conference, so let's put a round function on the outside of this just to give us a whole number. And then in this cell right here, it's an output, and so I've indicated that it's a psi output by going to results, output in cell, and selecting that. And when I do, then it adds this functional form on the end of that formula, whatever I had in there. Okay, so now when it's set up like this, it would allow me to run the simulation. I would need to go to the options and select 1 and 1,000, and OK. Then simulate, run once. It completes the run. If I double click on this output cell, then I see the distribution of the results for that cost based on the normal distribution uncertainty of the number that would attend. But my goal is to determine how many rooms to reserve, and so I want to look at that across a number of values. I want to look at it across 4,500 to 5,200. So to do that, in rooms reserved, I use a function called the SciSim parameters, or param, and then enter in that argument this range of values that I want to explore. Now with that, notice that there are 8 values, and so the way this would work, it would one at a time substitute the 4,500, then 4,600, and 4,700, and so forth into number reserve, run the simulation, and then store the results. I would like to have for each of these parameters run, have it record the mean and the standard deviation of that result. And so I can do that here by entering equal to psi mean, left parenthesis, the output, which in this case would be the cost, and then the simulation number, which would be this cell. But if I'll just put a dollar sign here, then I'll be able to copy this a little bit later on. So I can just copy this down, and that shows me my psi mean, and it's showing the same value because I haven't run the simulation at the different points yet. In a similar way, I can just also record the standard deviation by changing the mean to standard deviation, copying that across, and now for each of these runs it will record the mean and the standard deviation. Okay, so we have one more step to go before we run this. We go back to the options, and we enter the number of simulations we're running, which is equal to the number of values that we have entered into that psi_sim parameter function. And recall that's 8. So okay. It's showing the NAs because we haven't run it yet. Simulate, run. It gets the results. If I were to highlight these rows, go to Insert, Scatter, what it would show me is this cost curve, where we have the cost on the horizontal, the standard deviation on the vertical. And so you can see that the cost is decreasing as we come this direction, and then it sort of takes a turn and then starts increasing. All right, so my lowest cost is actually right here at this point. Then the vertical distance has to do with the variability, the standard deviation around that average cost. And so we can see the trade-off if you go the horizontal distance and the vertical distance of the additional average reduced for some additional measure of variability. So if we then say highlight this range, conditional formatting, bottom 10, change that to 1. It shows that minimum mean cost is here around 4,700, and you can see that the minimum standard deviation is 82 out here at 5,200. But this is about at that bend point, and so it would minimize those two. That's it. See you next time.